Hey there, and welcome to the Algorithms section. In this video, we will be introducing you to algorithms. This is probably the most important part of the STL, so hold on tight because we're going to dive right in. The algorithms library defines functions for a variety of purposes, such as searching, counting, sorting, partitioning, transforming, etc. Everything we will talk about is defined in the algorithms header, with the exception of the numeric algorithms, which are defined in the numeric header. Don't worry, we will cover that when we get there. All of the algorithms operate on ranges of data defined as first to last, where the algorithm is inclusive of the first element and exclusive of the last. Last always refers to one past the actual last element we want to work with. Algorithms are broken into major groups. As you can see, the list of available functionality is extensive. It is basically everything you could need to do with a container or a range of data. As we progress through this section, we will cover these different types of operators and when they are useful. Unfortunately, there are too many to cover every single one in just one section. Honestly, I can make a whole video series on just algorithms. However, we will cover the most relevant ones and also provide you with the tools to quickly find and use all of the algorithms. I would like to take a minute to talk about execution policy. If you reference cppreference.com, you will see a bit about them. Execution policies were added in C++ 17, and they control how the standard library executes the algorithms. Many algorithms have overloaded calls that take an exception policy as the first parameter. There are 3 execution policies defined, as of this video. They are sequential, parallel, and parallel plus vector. Sequential execution is just the normal or default execution. It will run the algorithm in the calling thread. Parallel execution means that the algorithm can spawn threads and chop up the data to execute in parallel, possibly resulting in faster execution. And parallel plus vector is an unsequenced parallel execution, which means that threads could be interleaved and data could be processed in any order and on any thread. Using a different policy should be as easy as passing it to the algorithm function that you want to execute, just like this example here. However, there is some bad news. While execution policies were standardized in C++ 17, they have not been fully implemented across all compilers. As you can see in this table, only Microsoft Visual Studio and the Intel C++ compilers have support. GCC and CLang are behind in this feature. If you are using Microsoft Visual Studio, then you can play with the execution policies as you see here in this screenshot. Since as of now GCC and CLang have no support, and the MSVC has limited support, I will not be discussing this feature any further during this section. So why am I talking about them then? Well, because these videos aren't going anywhere, and if you are watching them in a few years in the future, GCC and CLang may have caught up and implemented the execution policy overloads of the algorithms. Now, after seeing this video and looking at my examples a few slides back, you can see how easy it is to use these new execution policies, and everything we'll show in this section will still apply. As a side note, one good way to compare what compilers can do is to use the Compiler Explorer available at godbolt.org. Here, you can test if your code compiles on several different compilers and use experimental versions of compilers that have not been released yet. Please note that you cannot run your code though, just compile it. Here is an example of the Compiler Explorer. Feel free to use it anytime you want. You can select new compiler versions here from this drop-down. As you can see, many different types of compilers are supported.